y double dashed minus 3y dashed plus 5y equals 3x squared. And we've got these initial conditions. Let's have a go at this problem. Let's solve for the associated homogeneous equation. Y double dashed minus 3y dashed plus 5y equals 0. Here we can write the associated auxiliary equation, can't we? Lambda squared minus 3 lambda plus 5 equals 0. Now we need to solve this. So let's use the formula. Minus b is minus minus 3 plus or minus. Square root of b squared minus 3 squared is 9. Minus 4 times a, which is 1. It's one lot of lambda there, squared there. 4ac, which is 5. All over 2a, isn't it? 2 lots of a is 2 times 1. So what do we get? We get 3 plus or minus. 9 minus 20 is minus 11, so that's going to be a root 11i over 2. So we got a complex root here. This is case 3. Gives... Let's have a look at case 3 then, complex roots. So over here we've got complex roots, case 3, we've got a solution here, a sine beta plus b cos beta x, all times by e to the alpha x, where alpha and beta are the components of the complex number, like so, alpha plus I beta or alpha minus I beta. So it's a sine plus b cos times e to the alpha x. So gives, so yh then is a sine beta. Now beta was the part here, the component of the imaginary number that's here, root 11 over 2. Root 11 over 2 sine beta x plus b cos beta x, all times by e to the alpha x, wasn't it? Now alpha is the real part of this fraction here. See, the 3 over 2 is the real component, so it's 3 over 2, lots of x. So there's yh, done. Now we'll focus on yp now, to get the particular solution, part of the problem. So here, what do we try? Well, the right hand side is 3x squared. Let's go to our table, that's here. So this is what we try. So let's do that then. So try yp is equal to ax squared plus bx plus c. Then if we try that, we'll see that y dashed is equal to 2ax plus b, and the constant goes to 0, doesn't it? And y double dashed, we need that also. Will simply be just 2a, won't it? 2a there. Because the b goes to 0 and x goes to 1. 2a lots of x, so it's 2a. So there's our values. So substitution then gives, so let's sub it into the equation and see if we can determine the values of a, b and c here. So y double dashed, which is here, so 2a is y double dashed, minus 3y dashed. Now y dashed is 2ax plus b, plus 5y. So here's y, put it in, ax squared plus bx plus c equals 3x squareds. So if we equate the x squareds first of all, because that's the easiest thing to do, look along the row, we see it's 5a is here. 5a is equal to, on the left, 3 on the right. So that tells us that a is equal to 3/5. And that's 0.6 if we want to write it as a decimal. Next, what can we equate? Let's equate the x's, shall we? We should get a's and b's then, shouldn't we? So if we look at the x's, we've got minus 6a here for that x term when you expand the bracket, plus 5b. So minus 3a, minus 6a here, plus 5b there, and there's nothing on the other side. So that tells us then what b is. Move the 6a over to plus 6a. And then once that's moved over, we can move the 5 from times down to divide. And then what have we got? We've got 3/5 times 6/5, which is 18 over 25. If you times both by 4, you'll get 72 over 100. 36 over 50, 72 over 100. So that's 0.72 as a decimal, isn't it? So there's B. Now we need C. What's the easiest way to get C? So let's scroll down now, because we're focusing on YP at the moment, aren't we? So what about C? How are we going to get that? We've got to choose constants, haven't we? So let's do that. Not much choice here. 2A. And then we've got minus 3B. There. And then the constant here is plus 5C. Equals no constants on the other side. So then we can see that C is equal to, it's going to be this moves over to plus 3B. This moves over to minus 2A. Over 5, because the 5 can now come down from times to divide, because everything else has been moved over. So 3b minus 2a over 5, 3b. So that's 54 over 25, isn't it? Shall I put the fraction in? We can tap it in the calculator. But I'll just, I'm tempted to do it by hand. But no, I'll put it in the calculator so we're all happy with this, okay? So let's do it in the calculator then. I'll just put that over here. 3 times b, so it's 3 times 0.72 minus 2 times a, and a was 0.6. So that's the top part of the fraction. Divide that by 5, and we get 24 over 125. Let's get the decimal for that. It's equal to 0.192. So we'll deal in decimals because the fractions are starting to get awkward. So yp then is equal to a, which is 0.6, x squared, plus b, which is 0.72 lots of x, plus a c, plus 0.192. So there's yp part of the problem. So now we can combine them and get the general solution. So y equals yh plus yp. So let's scroll back up slightly to get yh. There's yh. Let's put that in. A sine root 11 over 2x plus b cos root 11 over 2x, all times by e to the 3 over 2, which is 1.5 lots of x. And then it's plus yp, so that would be plus ax squared. So here it is here, 0.6x squared plus 0.72x's, and then plus 0.192. There we go. So there's our general solution. Now we need to impose the initial conditions. Y0 is 2 and y dash 0 is 0. So let's turn our attention to that part of the problem now. So y0 equals 2 gives. So put it in. When x is 0, y is 2. When x is 0, so this will be sine 0 is 0. So you'll get 0 there. Plus cos 0 is 1, so that'll be b. Then you'll have e to the 0, which is 1, so that's times by 1, plus, and then x is 0, so all these are 0 except for the 0.192. So what do we get then? Well, b can stay where it is, and I'm reading from right to left. 2 minus 0.192. I'll simply move this 0.192 over, flip the sign to a minus, and note it down from right to left. And if you tap that in the calculator, you'll get 1.808. If you need to, there's the answer there, 1.808 for B. Now we need to differentiate. So differentiating now. Gives, so let's do the differentiation. Y dashed is equal to, this is a product, more than one term, so we'll treat this as the u part of the product, and this is the b. The b part of the product is itself a function of a function, and these constituents are also functions of a function. But let's just go ahead and proceed with the differentiation. So it's u, so I'm going to label this u, alright, and just write it down here. And then the v, so that'll be 1.5, that comes down e to the 1.5x, plus v times du. And this would be, this sine goes to cos, and the root 11 over 2 comes out to be with the a, and sine goes to cosine root 11 over 2x. So that would be v would be this times du dx, and I've just differentiated the first term here. Now we need to differentiate. Cos goes to minus sine, and it's minus, and the root 11 over 2 comes out again, times b sine root 11 over 2x. So that v I'm going to put as the actual value, e to the 1.5x here. E to the 1.5x. So it's u dv dx plus v du dx. That's this term differentiated. Now we can run along the row, differentiate this one. 2 0.6 is a 1.2x. 0.72x differentiates to just 0.72. So y naught equals naught then gives the constant goes to nothing, of course. So put naught, y naught equals naught in. Naught is equal to. Now if I put naught into u, sine naught is naught, b cos naught is 1, so we'll get b. So u is equal to b, isn't it? Save me writing all that out. E to the naught is just 1, so it's 1.5 times 1, plus 1, e to the naught is 1. Cos of naught is 1, so we get root 11 over 2 times a. And the sine naught is naught. Plus x naught is naught, this goes to naught, and we get plus 0.72. So now we can work out a. So that tells us now then that a is equal to, so let's move this over, minus 0.72 minus this stuff, which is 1.5 times b, and I'm going to write b in now because it was 1.808. So that's that term moved over and becoming a minus, all divided by, so I've moved this term over and this term over, and I've left the a where it is, and now I'm going to move these as well. So it's times by 2, divide by root 11. Yeah, because the 2 would then go up from divide to times, and the 11 would come down. So this is what we've got then. Let's tap it in a calculator and see what we get for a. So bracket minus 0.72 minus 1.5 times 1.808, close bracket, all times by 2 divided by the square root of 11. And then we need to press equals. Minus 2.07. 2.07 to 2 dB, that'll do. Hopefully. Minus 2.07. That's what we get for A. And we could double check that. Hopefully it's right. So we've got B, 1.808, which we could round to 1.81. So finally then, we can now write down our answer for our particular solution for this second order differential equation. Y equals, it was A, which is minus 2.07, sine root 11 over 2x plus b, 1.808, cosine root 11 over 2x, all times by e to the 1.5x, wasn't it? Plus, and then it was the values of the yp, 0.6, 0.72 and 0.192. So 0.6 x squared plus, and I'm going to have to remember again, 0.72x, and then it's plus 0.192.